All right, good afternoon, everybody. Welcome to the Lunch and Learn Wild Rice and Climate Change webinar, and thank you for joining us. My name is Sophia Patain, and I am the Communications Coordinator for the St. Croix River Association.
And I'm Katie Sickman, the Invasive Species Coordinator for the St. Croix River Association. For those of you that are not aware or just having a first experience with the St. Croix River Association, we are the official nonprofit partner of the St. Croix National Scenic Riverway, a unit of the National Park Service. The St. Croix River Association is dedicated to protecting, restoring, and celebrating the St. Croix River and its watershed. As a nonprofit organization, we depend on the support of individuals and businesses throughout the watershed to carry out our vital mission. If you are inspired by our work today, please consider becoming a member, volunteering, or participating at one of our upcoming events and sharing SCRA with your families and friends. For those of you who are already members, we thank you for your generous support.
Before we begin, we would like to take a few moments to talk about the Zoom software. Please leave your camera off and remain on mute for the entire webinar. You can type your questions in the chat box at the bottom of the screen. We will answer questions after the presentation, but please feel free to type them throughout the webinar. This webinar will also be recorded and a link will be sent out in the next few days. The recording will also be available to view on the St. Croix River Association's YouTube channel. As we move into questions towards the end of the presentation, we will put a survey in the chat box. Please take 3 minutes to fill out the survey. This will help us determine future Lunch and Learn topics and let us know how we are doing.
And today's topic will be wild rice and climate change. Our presenter today is Peter David, wildlife biologist with the Great Lakes Indian Fish and Wildlife Commission. Peter is a wildlife biologist with GLIFWC, where he assists GLIFWC's member tribes in the implementation of their off-reservation, treaty-reserved rights. He received his education, bachelor's and master's degree in wildlife ecology from the University of Wisconsin-Madison, and from the tribal elders and members for whom he has worked for the last 30 plus years. At the commission, he has had the opportunity to work with a variety of natural resources ranging from waterfowl to wolves, but his greatest focus has been on manoomin, or wild rice. He likes to spend his free time with his wife, Lisa, family, friends, or even himself doing something in the outdoors. Please join us in welcoming Peter. And Peter, please feel free to share your screen.
Hello. First of all, I'll just say hi and thank you for the invitation. Katie and Sophia, it's a pleasure to be here, to have the opportunity, and thanks to everybody who tuned in. And with that, I will turn on my screen sharing. It says it's going to stop other people, but I guess that's all right. And I am going to shut off my video here. All right, everybody see that all right?
Looks great, thank you.
All right, well, Buju, hello again, and thank you all for coming here today. It's always a pleasure for me to talk a little bit about manoomin. It's something that's become very near and dear to me and my family. Even though some of the talk today will not be all that pleasurable to think about, but manoomin has been a great blessing for us. And I hope that you can develop a relationship with it too. Really going to focus today on some of the, well, maybe the primary threat that wild rice faces right now, and that's in climate change. But I'll do that by starting off by giving you a quick ecological overview, because I think if you think about the life cycle of the plant and those kinds of things, it'll make it pretty clear why climate change represents a lot of threats. And I think as I'm not a climate scientist by any means, but I have been working with and observing rice beds for over 3 decades. And I think it's pretty clear that manoomin is telling us that it needs some help. So first of all, what is manoomin? We'll jump right into that. Okay, first of all, there's actually 2 species of wild rice that can be found here in the Midwest. This old picture actually goes back to what is southern wild rice by common names, Zizania aquatica. And this is a very tall plant. You might find it in Wisconsin, along the lower Wisconsin, along the Mississippi, and some southern distribution in Minnesota as well. It's very closely related to the plant that I'm really going to be talking about. But it turns out this plant, despite being as big and as robust as it's depicted here in this picture, actually has a relatively small seed. And so it's never been terribly important to human harvesters. And so I'll be talking about northern wild rice, Zizania palustris. And this is the one that has a large seed and that has been important to human harvesters for a long time. And manoomin, especially northern wild rice, has this fairly limited global distribution on the landscape. That's really only found in abundance in northern Wisconsin and northern Minnesota and adjacent parts of Canada. And I think that tells us a couple of things. First of all, this common name, northern wild rice, gives you a suggestion right off that this is a plant that's adapted to fairly harsh northern environments. And so you can imagine it might be susceptible to climate impacts. And also with this small global distribution, this is the only place in the entire globe where it's naturally found. It really puts the onus on us to be good global stewards. We can't count on people in another part of the world to take care of it. Now, rice is an annual aquatic grass. And the fact that it's that annual is really probably one of the most important things you need to think about in terms of climate impacts. It also, I think, suggests that because it is an annual and you've got an entire new generation every year unfolding, that it's probably going to be more responsive to climate change in some ways than very long-lived species. The very basic habitat preferences are very well known, I think, for rice. In short, it grows in about 1/2 foot to 3 feet of water. Likes water that's neutral or certainly not acidic, not too darkly stained. It likes annual water levels that are not terribly excessive in any particular year, but also actually year-to-year conditions that are not too stable. You actually need some high water years and some low water years to sort of create the disturbance that keeps a foothold on the landscape for this annual plant to grow. It likes rich organic mucky substrates, generally preferred, although rice sometimes grow on fairly firm bottoms, especially on some river sites. It also requires areas that are low in sulfates or sulfides. And if you've been following issues in Minnesota in particular, background levels typically are not a huge issue, but where mining or other activities can elevate sulfide levels, it can be very detrimental to rice. And finally, the other thing that rice really requires is this gently flowing water. And I'm lucky, I guess, as a biologist. Healthy rice beds have this pretty distinctive bright green color. And so I can identify it generally relatively well from the air. And you see rice growing on places like this, on rivers with these meander areas, especially where the nutrients tend to settle out. You see it on lakes that have inlets and outlets. You won't find rice growing on these places that are landlocked lakes. It requires this flow of water through the system. And that certainly describes many parts of the St. Croix River, but the area, I think, maybe with some of the best known rice on it, is up near the very upper parts of that river, from upper St. Croix Lake to the west end of the St. Croix flowage. And this is a shot of that just from a year ago, 2019, and the really lush rice beds that occur there. This is an area that many local people refer to as Cutaway Dam, even though the dam there is gone. The old Cutaway Dam was once used to drive logs down this system. This is the view up and downstream from the Cutaway Bridge that's still there, a snowmobile crossing. And the really beautiful rice beds that tend to grow there. I don't know that anybody knows just how long this rice has been there, but it's certainly likely it's been there for thousands of years. It was known or was recorded to be there back in the about 1830s when Lieutenant James Allen came through this area and created this map. And you can see the spots that he noticed and recorded the wild rice that was present there. You know, those early trappers and voyageurs were using these riverways as their highways. And so they came across these beds that were at that time quite abundant in the state. Now, getting back to the life cycle of rice, if you kind of take all the beauty out of this here and reduce it down to a diagram, you'll see that wild rice has a lot of living basically to pack into about a half-year long growing season. And so it's interesting to think about that. There is early spring submerged leaf stage. There is the floating leaf stage that's circled here. Circled because that's oftentimes considered to be a fairly critical point in the plant's development. The plant is naturally buoyant, but the roots are not well developed. It's growing in these soft sediments. So that's a point in time when it's fairly easy to have negative impacts on the rice, either by drowning it out or wave actions or storms uprooting the plants. Eventually it becomes emergent. Typically around the 4th of July, the plant starts becoming emergent. And will tend to grow up there through August or early September when maturation takes place and those seeds are being produced. And if you're a harvester, that's the time you're really interested in being in the rice beds. It is also worth thinking about that rice seed, and any of you who've had wild rice even on your plate know that this is a pretty large grain. And it has a very limited dispersal ability. And that too is another factor that probably has some significance when you think about climate change impacts, that this plant can't readily move very quickly into new areas of habitat that might be becoming suitable as the climate changes. Now, because rice is an annual, rice beds tend to look very different at different times of the year. And so this just sort of gives you that idea of how different this is. This is rice beds on the Bad River Reservation along the Kakagan River, but very early in the spring there before leaf out, those seeds are already probably starting to germinate in the top left. You see an image of that floating leaf stage, early emergence, and then again, about the 3rd week of August here on this particular river. This bed ripens up quite early in Wisconsin, one of the earliest spots actually to mature. But you can see the plant starting to brown up. And again, if you're interested in harvesting, that's the time of year you're interested in being out there. It also, because it's an annual, can show tremendous year-to-year variation. And so these pictures were all taken in August, but in 3 different years. And they show you how dramatically rice can vary from year to year. And this is truly a natural part of the ecology of this plant, especially on more lake-like environments. On rivers, there seems to be enough inflow of new nutrients and things that those beds tend to be more consistent from year to year. The more lake-like the environment becomes, the more this variability steps up. And I say probably one of the first lessons in TEK, or traditional ecological knowledge, that I got from the Ojibwe elders was what they call the 4-year rule. And that is that in a 4-year period, you could expect rice to have very good crop, like maybe shown in the top of this picture. A couple of years that might have fair to middling crops, like you see on the lower right. And not unusual at all, or to be expected that you might have 1 year that's a failure or a near failure. And some of this goes into things like nutrient cycling in the beds. Now, manoomin has tremendous value culturally. I always have to at least touch on this very briefly, although this will be highly inadequate in that regard. But here in Wisconsin, the Menominee Indians actually take their name from this plant. They're the wild rice people. At the Great Lakes Indian Fish and Wildlife Commission, where I work, our member tribes are Ojibwe, or Anishinaabe, and they have a tremendous cultural connection to manoomin as well. And it goes back to the migration story, where the Anishinaabe were once living along the eastern seaboard and actually following certain prophecies that indicated that if they were going to survive as a people, they had to move west. And they didn't really know exactly how far they had to go or where their ultimate destination was. But the prophecy was that they would be at their destination when they came to the place where the food grew on the water. And when they reached probably after a period of hundreds of years of gradual migration with stopping points along the way, but when they finally reached this Western Lake Superior region, the wild rice bowl of the world, those prophecies were fulfilled, and it makes this really a religious motherland to the Ojibwe as well. Rice, of course, has tremendous ecological significance as well. And you could do, a whole hour just on some of these values, but to touch on them very quickly, there's just such a broad host of species that benefit from rice, either the structure it provides, the cover, the food, and all of these different species. Black tern's a species not doing terribly well, of concern in this region, but we oftentimes find them associated with rice beds. The recovery of trumpeter swans in the state has been really interestingly strongly aligned in both states, I should say. I see we have a lot of people from Minnesota on the call, but very heavy use and selection for wild rice beds. On the top right, if that's a bird you're less familiar with, that's a soar or rail, is known simply as a rice bird to the Ojibwe. And rice harvesters are familiar with them because they're constantly sort of flitting around through the rice beds in the fall and are often seen by harvesters at that time. Of course, fur bearers love it. Muskrats feed on it. They make their dens out of it. They also create openings for waterfowl that probably actually enhance some of the use by dabbling ducks. I probably don't have to tell people how famous it is as a duck food. It's renowned for that purposes. And then my other image here, just of the rice across a windy spot, a reminder that I think rice can also even help in ways like dealing with the water quality, helping to maintain good water quality. Again, it's growing in places that have shallow systems, nutrient rich, and rice can take hold in bottoms that are oftentimes too soft for a lot of other plants to take root. And so they hold those sediments together, they break the wind action, they keep the nutrients down in the sediment really where you want them and not up in the water column where they're stirred up and feeding algae blooms. So this is just a scratch at the surface, but it's a tremendously valuable ecological plant. Despite all these tremendous values, we know that rice is facing many threats on the landscape right now. And I am going to talk today primarily about climate change, but I'm going to detour for 1 minute and just mention that I think historically, a lot of the early losses of wild rice that went on really had to do with disruption of the natural hydrology of areas. And actually in other talks I've given, I've often gone back to that Allen map and used that as an example. So if you take a look at that area today, people who are familiar with it, and you superimpose what that landscape looks like, how much it has changed, it is pretty striking. We have the tremendous systems of highways and roads. We have ditches. There's several dams of various sizes on this section now. There's cranberry operations, there's airport strips. So there's been, a lot of alteration to the landscape in the last 200 years, certainly more probably than occurred in, maybe 5,000 years prior to that time. And so we lost a lot of rice once upon a time, I think, in different places due to these changes in hydrology. But now we've got some new threats on the landscape taking place. So to take a look at climate change, we'll jump right into it. I think it's a long list, but nearly every sort of prediction of how the landscape is changing in the face of climate change brings negative impacts for rice. And again, when you think about the life cycle, a lot of these will be pretty obvious. First one is just a longer growing season, actually favoring other vegetation. So, a longer growing season might not be one of those things that just sort of is obviously a problem. But this is, again, a plant that is extremely adapted to harsh northern conditions. And in fact, it needs things like a long period under the ice, under low oxygen conditions for the seed to break germination. If we look at what the climate scientists tell us, if you look at Burnett County, for example, it's sort of a hotspot for this lengthening of the growing season. This is the highest density of rice abundance in Wisconsin. And in that area, they saw an increase of approximately 4 weeks in that growing season, just from 1950 to 2006. And now this data is already 15 years out of date, and you can imagine how this is trending. And this is a very real concern, I think, for a plant like wild rice. Another concern we have is the potential impacts from pest species and how that might be changing with climate change. And a lot of this, I'd say, is a concern at this point. We certainly need more science and more understanding to back this up. But the pest that we tend to be most concerned about with manoomin is this little critter, which if there's ricers in the audience, they're no doubt familiar with it, commonly called a rice worm. This is actually the larvae of a moth, and that moth will lay its eggs right in the grain of the wild rice, the developing grain of wild rice that you see on the right here. Those eggs hatch. Those larvae will eat that developing grain, chew their way out, and move on to additional grains. And people who have rice at the cutaway location, I think, are probably particularly familiar with it. For some reason, that section or that area seems to have fairly high levels of rice worms on a regular basis. But they can be pretty impressive. This was just a little piece of duct tape that I happened to have in my canoe when I was ricing at one location where the outbreak was pretty high. And you can see what happened in a fairly short period of time of these worms crawling out of the rice and getting stuck on that duct tape. And if you think of each of these worms now has probably consumed several grains of rice, at least in its development, this can have a pretty significant impact. And we're concerned that that overwinter survival, for example, might be increasing in this species as we move into milder winters. Also concerned about the relational impacts that are taking place with invasive species. Now, invasive species, of course, are a problem regardless of climate change. But I think there's two things that happen here. One is that the milder the climate comes, it seems the longer list of species that you're competing with tends to become. And these are just a couple that we've been concerned about, the curly-leaf pondweed and Eurasian water milfoil. The second thing that takes place is that many lake associations obviously are really concerned about addressing invasive problems. But it can be really hard, I think, in a lot of ways. We're in our infancy in understanding our ability to negatively impact these invasive species without having the ability to also have some negative impacts on native species like wild rice that we want to protect. Another one I'm sure that you can imagine I was going to get to here were these more frequent heavy rain events, and actually also very high wind and even hail events. But I'll talk primarily about rain here. This is something we're really seeing a lot. And if you think about it, particularly happening when rice is in that floating leaf stage. And if you think just about this part of the world in just the last 10 years and what we've witnessed, it's pretty shocking, I think. People who have been around for a little while remember the big storm of 2012 that hit parts of particularly Minnesota. And that storm has been described as the most damaging flood in Duluth's history. And when you looked at it, people who've been up to Duluth, this is the Target store there in the right side of the image. Tremendous impacts from that rain event, and this hit over a couple of days there in late June, right when rice was in that floating leaf stage. Of course, the news stories tend to focus on this kind of an impact, understandably, but it was also having tremendous impacts on rice beds. And just a couple of examples of important spots there in Minnesota. This is Flowage Lake in a good year, and the way it looked the year of that storm. Mallard Lake, another site. And of course, I already told you that this kind of variability or these kinds of failures do occasionally happen, and we expect them. But that year, in 2012, with that storm, the impacts were really dramatic on a broad part of the Minnesota landscape. I've got a little bit of a chip on my shoulder, perhaps. I do most of my manoomin stewardship in Wisconsin, and Minnesota has about probably 5 to 6 times the rice abundance that we have in Wisconsin. But 2012 was the only year in my career that I had tribal members from Minnesota wondering if there were places in Minnesota in Wisconsin that they could come and pick. So it was really pretty dramatic. Of course, you get through a big, 100-year or 200-year storm and you expect to be okay for a while. But it was only a little over 4 years when another major storm hit. Some of that same area in Minnesota, this one also came and extended into Wisconsin quite a bit. This one, fortunately, was just a little bit later. Even coming there in approaching mid-July, those plants were a little more developed, and that helped, I think, those roots stay rooted through the storm impacts. Also, with the exception of the rice beds up in the Coggin Sloughs on the Bad River Reservation, this storm fortunately was centered a little bit out of primary rice range. But the impacts again were dramatic. This is from the Bad River Reservation. And you can see this is that circle at the top there as part of the tribe's powwow grounds. Tremendous impacts there. It's a good thing that the Great Spirit can walk on water, but people had a hard time getting to church there for water after that flood. But now we've had 2 really major storms just 4 years apart. We got to be good for a while, right? Well, 2018, what some people have called the Father's Day storm hit here in parts of northern Wisconsin. Another really dramatic event. That dark circle shown here north of Hayward actually was classified as a 1,000-year storm event. And that other circle to the left of it there, a little smaller, but another very intense pocket, that falls within an area that is headwaters to some of the streams that feed into the St. Croix River, including a couple of streams that feed into a very nice rising spot known as the Radigan flowage. And that you can see the picture here, 2 different tributaries come together at the Radigan. This is in Douglas County, Wisconsin. You can see in the circle, there's a dam there. This is a human-made flowage that created some very good rice habitat. And if you look at it, this east branch of the flowage, example of the good rice beds that can exist there in a good year. The same is true up in this patch from the northwest branch of that flowage. Really important ricing bed. This particular site in Wisconsin, again, where rice is not terribly abundant, it held roughly about 1% of the wild rice in the state, okay? You can imagine the impacts. This was about a 7-inch rain event in certain areas, and it was pretty devastating. The dikes on Radigan actually had only been rebuilt maybe about a decade before this and were thought to be in good health, but that storm knocked them out, wiped out the dikes that held that flowage back, and the flowage drained. It doesn't exist at this date. We have some hope of eventually being able to rebuild this. Hopefully, actually, next year, there's some plans for this to take action, but it has now been totally dewatered for several years. And, you can get in all the complications of government regulations and the assist of FEMA, but FEMA doesn't like to pay for things up front. They like to reimburse. So this is a tremendous challenge for the town to find the funds to rebuild this and get that reimbursement. FEMA also likes to build things back to the level they were at. And that really probably doesn't make sense in a landscape, again, that's changing. We probably need to build this thing up now, not to the 100-year or the 200-year storm standards, but for what we used to think of as a 500-year storm, perhaps, or something like that. I also just want to mention, I said I wasn't going to talk about harvesting rice today. Maybe we could do that another day sometime, but this is that branch that I showed you in the previous picture up on the northwest. And I love to share this picture just because if you look closely at it and you see those parallel lines running through that rice bed, I happened to fly over this one just a few hours after it had been picked by some very talented rice pickers. It almost looks like they had been using a GPS to make these very systematic back and forth passes through the rice bed to harvest that grain in a very orderly and efficient and respectful manner. But to me, it's just such a great picture. I have to share that one whenever I can. Another thing we're concerned about are increased disease outbreaks. And the one that we're really concerned about with wild rice is a thing called brown spot disease. And this is an example of what it looks like in a fairly modest outbreak. And when it gets more severe, you can see leaves that look like this. And this is a fungal disease. It's been around for a long time, and we used to see it occasionally here and there in different places on the landscape, but it seems to be becoming more and more prevalent. It just likes warm, wet, high humid conditions that we're seeing more and more of. And that's a big concern. In Wisconsin in 2010, we had almost a crop failure across the state because of this disease. And when it's bad, you don't even have to be on the ground to detect it. You can see that healthy green color of the rice bed that I talked about disappear as these plants look dead months before they should be. And when they are heavily infected like that, the nutrients can't get up to the stem, can't fill out the developing seeds. And so you've mined the seed bank. Seeds have germinated, plants have grown, but the seed bank isn't replenished, and it's also not producing food for humans or for all of the other, what the Ojibwe refer to as the more than human beings that are also benefiting from the bounty that manoomin provides. And of course, as these things, and I'm sure there are other likely impacts, the other thing that's taking place is that these are all happening cumulatively. It's not one thing at a time or at one place at a time. The biggest threat, I think, about climate change versus every other threat that we see is that it's really happening across the entire manoomin landscape. And it's interesting to me to think about the impacts that rice is showing us. And this is a series of pictures from a lake in Minnesota, Dean Lake, tremendously important rice harvesting water and has been for centuries. And this is the rice crop over the last 12 years. And if you look at these closely, you can see that in this time period of 12 years where we might expect perhaps 3 failures, we've actually had 5 failures take place. 3 of them associated with outbreaks of this brown spot disease, another one in 2012 to that big flooding event. 2011, we're just less sure about it. At least I'm less sure about why that water failed. But we're seeing this increased failure rate occurring, and that's a big concern. I don't think biologists understand well how many of these failures can you have on an annual plant like this before you really start incurring long-term decline in the resource abundance. One other thing that we're seeing here, just in case you needed other things to be concerned about, and these days I don't think anybody does, unfortunately, but there have been recent studies with other crops, fairly closely related crops like rice, wheat, barley, and soy, that when those things are growing at the higher CO2 levels that are expected to occur by the end of the century, their nutrition level actually declines. And this is fairly marked. Wild rice hasn't been looked at in this regard yet, but I suspect that they're probably going to find similar kinds of declines taking place there. And when you're Ojibwe or in the non-Indian community that chooses to make manoomin a significant part of your diet, this is a really big concern. This is a tremendously nutritious plant. The food that grows on the water, in fact, was the most nutritious food that was available to the native diet in this region. And it's been critical both culturally and nutritionally for a very long time. And so declines like this are a very big concern. I'll have to say, I think we're struggling with ideas about how do you respond to this. There are some things perhaps that we could do. More intensive monitoring and management might help at a place like Radigan. Perhaps if we had automated water level monitors that could have alerted people, there might have been some greater opportunity to open the floodgates or to respond to those events more quickly than is typically possible right now. Building those dikes and those water control structures to higher standards can help to some degree, but of course, all of that stuff is fairly expensive. I think there's some modeling work that we can do that can at least help us get an idea of what spots on the landscape are going to be more susceptible to damage. Small headwaters lakes may be less likely to be negatively impacted than larger systems downstream, for example. There may be, we don't really know, but there may be some rice out there with some genetic resistance. There's some questions about that. I will say that for the tribes that I work for, there's a lot of concern about genetic manipulation at the same time. There's a strong cultural belief that manoomin was a gift from the creator that was really given in its perfect form. And what you really want are healthy and robust beds on a natural landscape, and that we shouldn't have to genetically manipulate this gift in order to protect it. Other things like thinning the beds, this is a hard thing to consider perhaps from a cultural perspective, but it might provide some benefits against things like brown spot disease with a little more airflow through the thickest parts of the beds and those kinds of things. Plants might dry off faster and be less susceptible. But there's a lot of questions. I think people basically have to start thinking about things that really they never wanted to have to think about before. And all of this goes back to the Ojibwe's idea of thinking ahead to the 7th generation. I think I was very happy to see Annette Drews in the audience. And I've borrowed this picture of Annette's and used it many times because this is really what it all comes down to. That this is a gift and we want to keep it. Tribes are intensely interested in keeping this special resource, this gift from Gitchimanadu on the landscape. The tribes talk about thinking in terms of 7 generations, that 7 generations from now, people living then should be able to look back to us and see that we considered them and thought about their needs. And it's something I've often thought about because the treaties where the tribes that I work for reserved off-reservation rights, those treaties were signed roughly 7 generations ago. And I actually, even though I'm not a tribal member, I have benefited from that foresight that those Ojibwe elders showed to reserve and to retain these rights, to steward these resources. And hopefully 7 generations from now, that'll be the case as well. And I think that's about all I have. I would be happy to take any questions. And they do have our contact information. That's our phone number. My extension there is 2123. And even though I'm working at home, messages will get automatically forwarded to me. Or you can track down my email on our GLIFWC website. But I think I'll leave it right there and stop the share, and we can perhaps take questions.
Thank you, Peter. We've had a lot of wonderful questions added into the chat. And we'll go down the list with as many as we can fit in here. First question comes from Dawn, who's wondering, Can you please explain the mechanism by which higher sulfides impact wild rice?
um, it's complicated. It's complicated chemistry, and I am not going to give you a very adequate response on that. There is research that John Pasture particularly has led, that part of it looks at the deposition of sulfide on the root masses, and it may be hindering nutrient uptake in the plants. But I think there's a number of things there too that also need further study. So the relationship between those high levels and declining rice is well understood, but the mechanism of that, I think, still has some things to be resolved. Although there may be people on the call who frankly can give you a better answer on that than I.
Thank you. We'll go to the next one from Laura Lee. She asks, one second. How can I nurture a bed in the Mississippi River in Cohasset at my family cabin?
Well, that's a good question. You know, there are a number of things certainly people can do to protect rice and to plant it in some places. GLIFWC has seeding guidelines that we happily share with people who are interested if they think they have habitat that's suitable for rice. Other things you can do if you have a good bed in your area, a lot of it is really just to try to minimize those impacts on it. You certainly don't want to be boating in it, especially during that early floating leaf stage. You try to keep people out of that. Harvesting rice, we actually always say, is a very positive thing. We think that harvesters become stewards of rice. And so you develop a relationship with rice by becoming a picker. You tend to watch out for it. You tend to want to protect it. And so we encourage harvesting and really think that's a good thing. Harvesting also takes actually a very small percentage of the seed, so it doesn't have negative impacts on the rice when it's done in the proper way. But generally, you just want to try to do those things to protect that rice and to really avoid the negative impacts. If you can have a system that's pretty naturally functioning, the rice will probably do a pretty good job of taking care of itself. So it's mostly a matter of not hurting it rather than helping it so much.
Thank you. Very interesting. This is fascinating, Peter. Our next question comes from Arlene Swenson, who is wondering what the name of the bridge you mentioned early in your presentation is, and if it is available for public access.
Yeah, it's the road that leads into that site is called Cutaway Dam, and that's in Douglas County, Wisconsin. It's fairly easy to find, just a few miles below Upper St. Croix Lake there. And it's a dirt road that takes you down to that site, but you can walk into that bridge park within 100 yards or so of that location. And it's a pretty common access point to the river there. It's a beautiful part of the river, I think, and the rice beds there are really gorgeous. So if you're ever in that area, it's worth taking a look.
Awesome. Next question is from Jerry Dorff. He asks, what is the difference or differences between wild rice that you've talked about today and cultured wild rice commercially grown? Where and under what conditions, example, climate, ecological, etc., does it grow in that is different than the wild rice?
Yeah, that's a great question. So, you know, if you go back less than a century, the only thing there was wild rice. And folks who, you know, even companies like Uncle Ben's, they obtained their wild rice by going around to lakes in northern Minnesota and Wisconsin and buying from harvesters. And then people got interested in perhaps domesticating this plant. And so they have been working for 70 to 80 years, I guess now, to do that. And you know, there are a number of differences. The plant is genetically somewhat different because it has been bred to have certain traits that are good for growing rice in a cultivated paddy situation. And so there's some genetic differences. It's grown there in a paddy, essentially. It's mechanically harvested. It tends to be, it might be treated with herbicides or fungicides. Things like brown spot disease is less of an issue if you are treating with a fungicide. That's typically not the way we want to manage in natural beds. And so it's an agricultural crop. And then flavor-wise, it's quite different too, in part because it's finished quite differently after it is harvested. And that has a lot of impact on the cooking and the flavor characteristics of wild rice. So if you've never had both, it's really valuable, I think, to do a side-by-side taste test because they're really quite different products. You can imagine real wild rice, which tends to be hand harvested in sort of small batch finished. It's typically not soaked, which is a common step done in the cultivated industry. As I mentioned, cultivated rice is mechanically harvested. And so they basically do one pass with a combine. And that sort of is picking all of the rice, regardless of sort of its maturation level. Whereas hand harvesting goes on and picks a bed repeatedly, sort of like a strawberry patch, picking only what's ripe at a certain time. And so there's really a host of different differences that come into play. And so certainly do encourage people to become familiar with the differences between the two of those and see which one you really, really like the best.
Wonderful. So our next question comes from Elena, who's wondering, are there programs where they clear the dying rice beds or do they not do that?
I'm not familiar with anyone who's done that or any need to do that. The rice beds, by springtime, typically you don't see any of that. In some cases, the rice straw, if you will, the leftover of the plant after it has died, that falls back and it goes down into the sediment. The rate of that decay can vary a little bit depending on the situation. There's some value in having the plant decay slowly in a way. For example, those root masses help hold that sediment together even when the plant is dead. But that root mass and those other things also hold some of the nutrients. And on those lake environments, that's probably one of the reasons why abundance is variable. That when you have a real good crop one year, some of those nutrients haven't decayed and they're not available for the crop the next year. And so that may put a dampen in the next year. But I'm not aware of anyone who would actively be removing rice straw. And generally, you probably want those nutrients to stay in the system instead of harvesting them out. Now, in a few very nutrient-rich systems, that might be something to think about, perhaps. But yeah, not familiar with that.
Great. The next question is from Jed. He asks, do you have info on the progress of VOYA or VOYA manoomin after the update of the water agreement?
I cannot respond to that, actually.
Okay.
Sorry.
Our next question is from Jill, who is wondering, is there any evidence that wild rice has experienced some level of domestication because it has been harvested over centuries?
Well, that's an interesting question. I don't know of anyone who has specifically looked at that. And I'm not sure what, it'd be interesting to me, I'm not a geneticist here, but to think about what would you be looking for to indicate that that was the case? Or what would be the signal to suggest that some form of domestication is taking place? Certainly, rice has been something that humans have probably influenced the genetics to some degree just by moving it and planting it. And so by moving seeds at certain times, we've had some impact. We don't think that that's been very significant in most cases. I've been personally concerned about an impact that we've lost a lot of rice beds. And rice is a wind pollinated plant. And so most of the gene flow probably takes place through pollen transfer. But even though it's wind pollinated, the distance of that pollen dispersal is fairly limited. And I've been concerned that if we've lost a lot of rice beds, we may be reducing gene flow between populations, because those, maybe the rice beds now are, 4 miles apart instead of 2 miles apart in places, and that gene flow through pollen can't make it. And actually that reduction in gene flow could be a concern or a threat, making those plants less adaptable in the face of something like climate change by sharing that genetic material that might be successful if one strain is developed that hasn't.
Very interesting. Thank you. And then we have another question from Gary and Marty saying, congratulations to GLIFWC on the completion of the widely acclaimed tribal adaptation menu. Does this document address manoomin?
Yeah, it does. You can find several pages in that document that addresses rice. And I was a tertiary contributor to that document, but I think that wild rice was really identified as perhaps the most sensitive species in GLIFWC's climate change documents. Now, it was interesting. Some of the tribes in Minnesota have done some similar work, and they tended to rate it slightly less significantly or slightly less sensitive than in Wisconsin. And I think that really indicates actually that our beds may actually be at a higher level of risk, especially in the southern part of the state. And because we have this Lake Superior to the north of us that really acts as a cap on rice abundance to the north. So, but it's, yeah, you can find that document, I'm sure, on GLIFWC's website and see the ratings that we generated.
Awesome. We have another question from Don. He asked, do you have a sense of what % of rice beds remain versus, say, 200 years ago?
Yeah, that's a great question. Annette Drews, who's on the call, maybe would want to clip in. She's done some work actually looking at this question. It's very hard, and it's also it's certainly variable across the landscape. In Wisconsin, again, where I've done most of my work, there were historically some tremendously big beds in the southern part of the state that have been lost. That the losses have been not as intense in the northern part of the state as in the south. So the question may have a little different answer in different parts of the landscape. But Annette, do you want to comment on that at all? Put you on the spot, if it's possible to make her go live.
There I go. Nope, I think I'm unmuted, right?
You're
Yes.
live now.
Okay. Yeah, that's a great question. In my research, I basically had access to like botanical surveys that are listed in herbariums and documented around a 25 to 30% loss, a bigger loss in Wisconsin than in Minnesota at this point. But those are very rough numbers because we've never really had a inventory per se, and those were watershed based, so they weren't based on how many acres of wild rice we might have had. It's a very difficult thing to do in Minnesota, and the tribes in northern Minnesota are going to develop some monitoring, but we just don't, we know we've lost significant, especially if you look at all the maps and place names and lake names. Rice is reflected, historically things were named by what was there. And so we find Rice Lake in many places where there's no longer wild rice.
Good wish, Annette. Good to see you.
Thank you. All right. So Sophia, do you want to share our final slide?
Absolutely. And if anyone has any remaining questions, please feel free to share.
And people can certainly contact me. My email's pretty easy. It's just pdavid@glifwic.org. So always happy to try to respond to any questions we don't get to in the presentation.
And Peter's email is also in the chat box if anyone would like to copy directly. Does anyone have any remaining questions? Want to make sure we answer everyone's. Going once. Going twice. All right. Well, thank you so much for taking the time to speak with us today, Peter. We are so grateful to you. And if anyone has any questions afterwards that they think of after the fact, please feel free to reach out to Peter directly. And we are hosting several more Lunch and Learn events. Our next Lunch and Learn event is coming up soon.
Yes, so to learn more about the St. Croix River Association and view our upcoming events, including our next Lunch and Learn event called Camping on the Croix 101, please visit us at our website, stcroixriverassociation.org. To be sure you do not miss another event, please sign up on our homepage to receive our e-news. And with that being said, we thank you for attending, and a special thank you to Peter. Have a wonderful day. It seems like in the northern part of Wisconsin, we have a beautiful day with warm weather, so get outside, and thanks again. And if you have any questions, please feel free to email Peter or reach out to SCRA at info@scramail.org. Thank you.
Thank you. Take care all.
Thank you, everyone. Have a wonderful day.